Alright guys, welcome to this page of the notes, and let's start off by talking about some terms that I'm going to be using pretty frequently, the language I'll be using throughout the next several sections here in chapter 6, and it's all about nth degree radicals. So here we go. First, let me grab my highlighter, a couple of things for you. First of all, the symbol, right? We know that we're going to be taking radicals, we're going to be taking roots of numbers, and the degree of the radical will change depending on which root you're taking, indicated by n. So, like I said on the previous page, n is what's known as the index, right? And so whatever number is in that index position, okay, will tell you which kind of root you're taking. Are you taking a third root, a fourth root, a fifth root, right? Based on what is the number there. And again, very, very important. If there's nothing there, it's a 2, right? You're taking a square root, right? So 2 is implied, it's not written. If it's anything other than a 2, we'll have to tell you what we want it to be. Of course, then there is the radical symbol, which you guys are very familiar with. And the last thing I really want to kind of point out is this. What's underneath the radical symbol, right? The A underneath the radical symbol is what's known as the radicand. It's what you're taking the root of. And this is actually really important. Let me show you a couple of things here. If I were to give you, sorry, not my highlighter, find my marker, there it is. Y is equal to the square root of A plus 1. Everything underneath the radical is going to be what we call the radicand. So in this case, right, I have an A plus 1 underneath the radical symbol. So A plus 1 would be my radicand. But it's just what's under the radical sign, right? So if I were to give you this, y equals 2 times the square root of A plus 1 minus 5. Well, my radicand is still an A plus 1. All this extra stuff doesn't change what my radicand is. The radicand is always just what's under the radical symbol, okay? So it's still just a radicand of A plus 1. The fact that I'm multiplying it by 2 and subtracting by 5 doesn't change my radicand, right? What's underneath the radical is your radicand. That's all that matters. Just look what's underneath the radical symbol. Don't worry about the other stuff. If I'm asking you to do something with the radicand, just find what's underneath the radical symbol. And then this other last little piece here before we actually get to simplifying down here is this idea. In previous chapters and sections, whenever you've taken a radical, actually, whenever you've taken a square root, you've always had to do plus or minus, right? And we know why that is. The reason that you always have to do plus or minus, just let me make a quick little note down here, is this. If I were to do a 2 squared and a minus 2 squared, in both cases, my answer is 4. Right? So if I were to ask you to take the square root of 4, if I were to ask you to take the square root of 4, well, you don't know which answer I want. Am I looking for the positive 2 or am I looking for the negative 2? Because both of those when you square them, they both get you 4. So which one do I want? Well, since you don't know which one I want, you've had to give me both. Whenever we would take a square root, we would just simply put a plus or minus out front, which means I'm doing plus or minus the square root of 4, which is, of course, plus or minus 2, right? Because you don't know which one is the one I'm looking for, so you have to give me both. Well, here in this section, it's actually going to be a little bit different. What I'm going to now do is I'm going to tell you which one I want. Do I want the positive root or do I want the negative root? And I'll do that by indicating to you which one I want. If there's nothing, if there's no sign out front, that means I want what is known as the principal root, the non-negative root. I want the principal root, so you just give me the positive value of that particular root. In this case, the square root of 25 is just going to be a 5. You don't have to worry about doing plus or minus 5 anymore. You know, because it's a positive sign out front, which of course isn't written, it's implied, I want the positive root. If I want the negative root, starting now in this section, through the rest of the chapter, if I want the negative root, I'm going to tell you. I will put a minus sign out front so that you know when you take the square root of 25, which is 5, you got to make it negative because I'm looking for the negative root. If I want both the positive and the negative answer, I will put the plus or minus out front. Okay, so starting now in this section, you no longer need to worry about doing plus or minus when you take a square root. I'll let you know which one I want by putting a sign out front. Okay, so let's go ahead and jump into simplifying some of these. Here we go. What I've got for you is I'm asking you to simplify the following nth roots. We've got a couple here, and actually we're going to start pretty simple. Please notice the index. There's no index written, which means you are to assume that it is a 2. All right, so we're going to go ahead and work on taking and simplifying these roots, and we actually start off with a couple of pretty simple ones. You guys will remember from the previous section, that whenever you have multiplication underneath of a radical, the product property allows us to split it up. So I'm going to simply rewrite this then as plus or minus the square root of 16 times the square root of y to the 4th. Now, not a problem. I know 16 is a perfect square, so I can take care of that. We'll get there. But I mentioned to you on the previous page of the notes, one of the things that we're going to need to do to simplify these guys is we need to get the index and the power to match. If they're the same, then they'll cancel each other out. And right now they don't match. I have an index of 2, but the power is 4. But I actually showed you on the previous page that I can rewrite y to the 4th. In fact, I can rewrite it like this. Plus or minus the square root of 16 times the square root of a y squared times a y squared. And again, the product property of radicals allows me to split those guys up. So let's go ahead and split them up. Plus or minus 16 times the square root of y squared times the square root of y squared. Well, now we're ready to go ahead and get our final answer, our simplified form of the original radical. Sorry, I forgot my square root on the 16. I apologize. There it is. All right, so here we go. The square root of 16, of course, is 4, so I'll have plus or minus 4. Because the index and the power are the same, they cancel each other out, and I'm left with a y. And the index and the power are the same, they cancel out. I'm left with another y. And because I have y times y, that'll be a y squared. So I have plus or minus 4y squared. Now, I took my time, right, because this was our first one working through it together. You know, I kind of went slow. I showed probably way more steps than what you're going to need to show. But for now, hopefully that makes sense. Really, that's what we're doing. And as we do more of these, I will begin to skip some of those steps that now you're in Algebra 2, you probably don't really need to show them. Anyway, let's go ahead and try this next one. Please notice I put a minus sign out front, which means I'm looking for the negative root in this case. And right away I recognize, okay, well hang on a second, my index is 2, but my power is 8. And that's not going to work. Those aren't the same, so they're not going to cancel out. So here we go. Let's try rewriting this guy. I'm going to do the square root. And then I'm going to do the x squared minus 6 squared times x squared minus 6 squared times x squared minus 6 squared times x squared minus 6 squared. Now, why do I do that? Well, it's simply because property of exponents. Whenever the bases are the same, you add the exponents. X squared minus 6, x squared minus 6, x squared minus 6, x squared minus 6. All the bases are the same. We add the exponents. 1, 2, 3, 4, 5, 6, 7, 8. Right? So all I've done is I've taken this guy and rewritten it. But why have I done that? Well, now I can use the product property to split all those guys up, and the index and the power are now going to be the same. So let me go ahead and rewrite this one more time. I will have x squared minus 6 squared, and I'll take the square root of that, multiply by x squared minus 6 squared, take the square root of that, times x squared minus 6 squared, take the square root of that, times, last one, x squared minus 6 squared, take the square root of that, right? So now I've used that product property to split them all up. The index and the power are the same in every single one of them, which means they just cancel each other out. So I'm left with minus x squared minus 6 times x squared minus 6 times x squared minus 6 times x squared minus 6. Well, base, all the same. They're all to the first power. Add the exponents. 1, 2, 3, 4. So as my final answer in simplified form, I will rewrite this guy as negative x squared minus 6 to the 4th power. And again, because this is sort of our first time working through these, I took this guy, I've written out all of my steps. I recognize, actually, you guys probably won't need to write all of that out. You can probably go from here to here pretty quickly just doing it in your head, and I am perfectly okay with that. That's fine. I just want to make sure that you can see what it is that's going on here. All right? So head on over to the next page of the notes. We'll try simplifying a few more. I'll meet you guys over there.